Assalamualaikum. In part 3 video for volumetric analysis, I will explain about the calculation of back titration. Okay, so there are two types of titration. Previously, I had explained direct titration. So in this video, I will explain about back titration. Okay, what is back titration? A titration where the concentration of analyte is determined by reacting it with a known amount of excess reagent. The remaining excess reagent is then titrated with another second standard of reagent. The second set titration will determine the amount of the excess reagent used in the first titration, and the original analyte concentration can be calculated. So in back titration, there are two-step reaction involved. Okay. So when complete reaction, come up with two balanced chemical equation. First reaction is reactant A of unknown concentration is reacted with excess standard reagent of reactant B, okay, where the reactant B is known concentration. Second reaction, a direct titration is then performed to determine the amount of reactant B in excess. This is the reason why back titration is applied. Okay. First, the reaction is too slow. Right, second, sharp endpoint is difficult to obtain. Next, one of the reactant is volatile, such as ammonia. Okay. Acid or base is an insoluble salt, and the reaction involved between weak acid and weak base. So there are formula to find mole reacted. The equation is initial mole minus mole excess. Okay, after this we look at the example. Okay, for back titration, there are two-step reaction involved. First step is reactant A or analyte will react with excess standard reagent. Okay, so when complete reaction, there are first chemical equation occur. Second reaction is excess reagent will titrate with another second standard reagent. Okay, so when complete reaction, when indicator change color in the solution in flask, so complete reaction occur, come up with another balanced chemical equation. Okay. So two reactions involved and there is two chemical balance equation. Okay, we look at the first example. 1.125 gram calcium hydroxide sample was dissolved in 100 ml 0.25 molar hydrochloric acid HCl. The excess acid is back titrated with 0.05 molar sodium carbonate, okay, the standard solution, and require 20.25 ml to reach endpoint. Calculate the percentage of weight per weight purity of calcium hydroxide. So, the reaction involved, first is calcium hydroxide plus 2 mole HCl to form product calcium chloride and 2 mole of water. Second equation, 2 mole HCl react with 1 mole sodium carbonate to form 2 mole sodium chloride plus carbon dioxide plus water. Okay, first you have to understand the situation or condition of this back titration. Okay, so initially, given hydrochloric acid, okay, the molarity is 0.25 molar with excess volume 100 ml. For sample calcium hydroxide, mass given 1.125 gram. Okay. So initial means when you prepare HCl and calcium hydroxide sample. Okay, but these two substances not mixed yet. Okay, next step. Okay, calcium hydroxide dissolve in excess HCl and put together into the conical flask. Okay, and undergo reaction. Okay. For example, in experiment 2 to study the calcium carbonate in eggshell. So during reaction between eggshell and HCl, the acid, so the flask containing sample eggshell and acid, okay, was react and put on a hot plate. Okay, so there are reaction happen. Okay, same with this concept. Reaction happen between acid, HCl and calcium hydroxide. So now HCl and calcium hydroxide has reacted and come up with one balanced equation between calcium hydroxide and HCl. Okay, the reaction is calcium hydroxide plus 2 mole HCl. So the product is calcium chloride plus 2 mole water. Okay. So after reaction occur, all the analyte in sample has reacted. Then the excess acid. Okay, now excess acid or excess HCl titrate with another standard solution. So in this case is sodium carbonate standard solution. Okay, so given molarity 0.05 molar and volume required to reach endpoint is 20.25 ml. Okay, so this is the volume of titer. Means that when 20.25 volume in ml of sodium carbonate deliver to the solution in flask is hydrochloric acid, so the indicator change color and endpoint. Okay, so at this point the reaction is complete, so come up with another balanced equation. Okay, so the equation is sodium carbonate plus 2 mole HCl to form product 2 mole sodium chloride plus carbon dioxide plus water. Okay, so The question is to calculate the percentage of weight per weight purity of calcium hydroxide means that the mass of reacted calcium hydroxide in gram over mass of total calcium hydroxide or sample calcium hydroxide in gram times 100%. Okay, so to find the percentage weight per weight purity of calcium hydroxide, you have to know the mass of reacted calcium hydroxide here. Okay, mass calcium hydroxide reacted. Okay, we reverse back how to find the answer. Before you determine mass calcium hydroxide reacted, okay, you have to find number of mole calcium hydroxide reacted. Okay, how to find number of mole calcium hydroxide reacted? So, you look at the drawing number 1 or number 2, okay, that has the substance of calcium hydroxide reacted. Okay, so here at equation number 1. Okay, for equation number 1, it involves mole calcium hydroxide reacted and mole of HCl reacted here. Okay, so to find mole calcium hydroxide reacted, here you have to know the number of mole of hydrochloric acid reacted. Number of mole HCl reacted by comparing from equation number 1. Okay, by comparison from equation you can find the number of mole reacted of calcium hydroxide. So to find number of mole of HCl reacted, okay, from the formula, initial mole of HCl minus with excess mole of HCl. Okay, so how to find initial mole of HCl? Here. Okay, from drawing the first initial here, okay, means that the acid not react with anything yet. Okay, kita tak mix lagi dengan sample tadi. So, from given molarity and volume, you can find number of mole initial HCl here. Okay, kat sini boleh cari initial mole HCl. Okay, you can calculate. To find excess mole of HCl, okay, so you look at drawing, which drawing that refer to excess acid of HCl. Okay, yang ni. Drawing number 2, where excess acid, okay, was titrate or standardized with sodium carbonate. Okay, so here is in drawing number 2, okay, refer to equation 2. So here where excess acid, okay, react with standard sodium carbonate. Okay, so to find excess mole of hydrochloric acid, okay, you have to find mole of sodium carbonate. Okay, you can find excess mole of hydrochloric acid Before that, you have to calculate first mole of sodium carbonate by comparing with equation 2. Okay. Okay, you look at the sodium carbonate pada equation mana? Okay, number 1 or number 2. So, to find excess mole acid, you have to calculate mole of sodium carbonate first. Okay, and then compare from the equation to find number of mole of excess acid. Okay, so have calculate excess mole acid. Okay, so the flow, how to get the answer, you can first calculate. Okay, you can first calculate initial mole first. Okay, then calculate initial mole of acid. Okay, total or initial mole of acid before reaction. Okay, first drawing, tak react mana-mana lagi, baru you prepare. Okay, so second, you find number of mole of sodium carbonate. Okay, given molarity and volume, so you can find number of mole of sodium carbonate, number 2. So by comparing the equation, you can find number of excess mole of acid. Okay, by comparing the equation. Then number 4, you can find mole of hydrochloric acid reacted by the value initial mole minus excess mole acid. Okay, yang awal yang total tolak yang lebihan dapat yang reaction. Dapat number of mole reaction masa reaction with analyte in sample. Okay, masa first drawing. Okay, from this one, reaction between acid and calcium hydroxide. Okay, so after calculate mole acid and reacted, this one, okay, kita dah dapat initial minus excess, dapat mole reacted. So to find mole calcium hydroxide reacted, okay, masa reaction ni nak dapatkan mole calcium hydroxide reacted, comparing equation 1 to get number of mole of calcium hydroxide reacted. Okay, so after you get mole calcium hydroxide reacted, you can find mass of calcium hydroxide reacted. Okay, from number of mole times molecular weight of calcium hydroxide. So in unit gram per mole, so you will get mass of calcium hydroxide reacted. Okay, kita dapat tahu gram analyte react. Okay, 7. After you find mass calcium hydroxide reacted, okay, put into the formula to find weight per weight purity of calcium hydroxide. So mass of analyte reacted divided by total sample. Okay, time 100%. So the purity means how many analyte react in sample. Okay, so this is the flow, how to get the answer like I explained just now. Okay, you find the initial mole of acid, and then from titration find number of mole of sodium carbonate. Okay, to find mole of excess acid, here compare equation 2 to find number of mole of acid. Okay. Next, after you determine initial mole and excess mole acid, you can. Okay. Now to find number of mole reacted HCl, initial mole HCl minus excess mole HCl. Okay. Then we will get number of mole reacted HCl. Right. Next, by comparing from equation 1, so we can calculate number of mole reacted calcium hydroxide. Alright. Next, we can find number mass reacted calcium hydroxide. Okay, and put into the formula weight per weight purity of calcium hydroxide. Okay, the formula is mass of reacted calcium hydroxide in gram. Okay, over mass of total sample of calcium hydroxide, both in gram unit, times 100%. Okay, so there are two reactions involved. Okay, first, from the reaction in conical flask, okay, which involve calcium hydroxide and hydrochloric acid to form calcium chloride and water. Okay, next reaction between hydrochloric acid in excess, okay, standardize or titrate with standard solution sodium carbonate. Okay, for equation 2. So the balance equation is 2 mole hydrochloric acid react with 1 mole sodium carbonate to form product 2 mole sodium chloride plus calcium plus carbon dioxide plus water. Okay, two reaction involved, so there are two chemical balance equation. So next we go for the solution part. Okay, so from the flow, okay, to find percentage purity of weight per weight calcium hydroxide in sample. So from the flow, first we have to find initial mole of HCl. Okay, this is the initial part where the preparation of HCl and the HCl not mixed yet with the sample. Okay, so 0.25 mole per liter, okay, given concentration for hydrochloric acid, okay, and volume in excess for HCl. So we can find number of mole of initial for acid. Okay, so 0.25 mole per liter times 100 ml change into liter unit. Okay, so cancel unit liter to find number of mole. 0.025 mole HCl initial. Okay, second step, after we find initial number of mole, okay, next to find mole of HCl excess, okay, we have to find mole of sodium carbonate first. Okay, this is for the second reaction during titration part between sodium carbonate and excess acid or excess HCl. So to find number of mole of excess HCl, we have to find number of mole sodium carbonate first. Okay, and then comparing from equation. So second step, find number of mole of sodium carbonate, standard solution. Okay, so if standard solution given in statement, the concentration or molarity. Okay, so molarity given and volume of titral given. Okay, where titral is deliver solution of sodium carbonate that react with the analyte. Okay, so given molarity, sodium carbonate 0.05 mole per liter times volume of titral in ml, you change into liter unit. Okay, and then mole per liter times liter, you get number of mole 1.125 times exponent negative 3 mole sodium carbonate. Okay. Step number 3. To find number of mole HCl excess, compare from equation 2. Okay. This is the second reaction. The first reaction during reaction in conical flask between calcium hydroxide and HCl. Okay, so from drawing number 2, by you get equation 2. By comparing equation 2, we can find number of mole of HCl excess. Okay, so previously number of mole sodium carbonate is 1.0125 times exponent negative 3 mole sodium carbonate, okay, times 2 moles of HCl over 1 mole of sodium carbonate. Okay, then we cancel unit of sodium carbonate to find our desired unit for mole HCl excess. So the answer is 2.025 times exponent negative 3 mole HCl excess. Okay, this is the important part. We comparing the equation number 2. Okay, don't forget to write the number of mole of unit. So for example, to get number of mole of HCl excess from number of mole sodium carbonate times the information from equation. Okay, so we want to cancel unit sodium carbonate. Unit of HCl must be in the above part. Okay, so write the unit and then you can cancel unit of sodium carbonate to find HCl. Okay, you must write the unit of substance. Okay, then you can understand the relationship and not confused. Okay, next, step number 4. Okay, since we have calculate the initial HCl and excess mole of HCl. Okay, step number 4, we can find number of mole reacted. Okay, the formula is initial mole HCl minus excess mole HCl. Okay, to know the mole of reacted HCl, okay, from drawing number 1, okay, to know number of mole reacted HCl here, initial total HCl, which does not react yet, minus excess, okay, yang lebihan, so we will get the number of mole of reacted. Okay, so 0.025 mole for initial HCl minus 2.025 times exponent negative 3 mole for excess HCl, then the answer is 0.02298 mole HCl reacted. Okay, so after we find number of mole of HCl reacted, to find number of mole calcium hydroxide reacted, okay, comparing equation 1, okay, from drawing number 1. So from mole HCl reacted that we find here 0.02298 mole HCl reacted, okay, by comparing from equation 1, okay, times 1 mole calcium hydroxide over 2 mole HCl. So we can cancel unit mole HCl, okay, to find number of mole of calcium hydroxide reacted. Okay, and then the answer is 0.01149 mole of calcium hydroxide reacted. Alright, so we compare from equation 1, okay, between calcium hydroxide and HCl. After we get mole HCl reacted, we can find mole calcium hydroxide reacted by comparing from equation number 1. Okay, so don't forget to write the substance. Okay, for example, 1 mole calcium hydroxide over 2 mole HCl, okay, times with mole HCl reacted. So we want to cancel unit HCl to find the desired unit mole calcium hydroxide reacted. Okay, so don't forget to write the mole of substance because there are 2 times comparison. First, previously here to find mole of HCl excess. Next, the second comparison to find mole of reacted calcium hydroxide. Alright, so if you don't write the unit of substance here, you will get confused. Okay, next step number 6. After number of mole of calcium hydroxide reacted, okay, that we have calculated previously, we can find number of mass calcium hydroxide, okay, by times number of mole calcium hydroxide reacted times the molecular weight. So this one calcium hydroxide, calcium plus 2 times oxygen plus 2 times hydrogen for atomic weight, and then you will find 74 gram per mole. Okay, so the answer is 0.85 gram. Okay, next step number 7. Okay, to find purity, percentage weight per weight purity of calcium hydroxide. Mass of calcium hydroxide 0.85 gram divided by mass sample. Okay, mass sample of calcium hydroxide given in equation 1.125 gram. So times 100%. Okay, the answer is 75.56% weight per weight.